So now I would like to introduce today's speaker. Dr. Sudan Gyawaly is an area integrated pest management advisor with the University of California Cooperative Extension in Butte, Sutter-Yuba, Colusa, Glenn, and Tehama counties. Today he's going to be speaking on major olive pests in California and their management. So you can go ahead and share your slides.
Hi, good afternoon, everyone. Thank you, Cheryl, for the introduction. So as Cheryl mentioned, my name is Sudan Gyawaly. I am Area IPM Advisor. So I'm based out of the Northern Sacramento Valley. And in my today's presentation, I'm going to talk about some of the key olive pests that we deal with and their management updates, basically covering how these pests are managed. So a small disclaimer here. So I'm based out of Northern Sacramento Valley. So unintentionally, my talk will probably be a little bit biased towards the pest problem we deal in the Northern Valley here. So without further delay, I would like to go ahead and start my presentation. So I will start with a brief overview of California olive industry. So California is a leader in the United States when it comes to olive production. So it produces about 84% of the total olive produced in the US. So it covers around more than 40,000 acres of land, of the area in the states, out of which one third of the total acreage is under table olive production, and the rest 2/3 is under oil olive production. So the GDP contribution from olive industry is about 144 million per year, and the production is primarily focused in the Central Valley, and although there is some production in the coastal area, it's mostly small small scale production in most cases. So in the Central Valley, we have two leading counties in the San Joaquin Valley, so Tulare and San Joaquin counties, and there are two counties that lead in the Sacramento Valley, that is Glenn and Tehama counties, as you can see in the map. So the olive industry has seen some significant changes over the years. It's mostly in terms of the types of olives that was produced. So prior to 2000, 90% of the olive produced was for canning purpose. But based on this information, this USDA data 2024, that had changed, and we have started to produce or focus more on olive oil production. So currently, more than 75% of the olive produced in California is for oil production. So a lot of things might have come into play for this shift in production. So labor cost, in imports, there is high demand for oil olive, so that market situation, and then some changes in harvest technology, such as the modern harvest technology favoring the production of oil olive has resulted in this change. So as of 2024 data, so there has been significant jump in the total production as well. So in 26, California produced about 2 million pounds of olives, which has now jumped into 21 million pounds of olive in 2021 to 2023, that data, based on that data. So even though we have started to produce a lot of olive, we are still a very big importer of olives. We import more than 98% of the olive oil to US market from mostly from European countries. So this is just a brief overview on olive industry. So because today's talk is focused on pest management, I would like to switch the gear and start talking about the thing that I love. So talking about pest management, we have UC IPM that lists several insect species as pest of olive, and because of the time limitation, a time constraint, I won't be able to discuss each and every pest. So my talk today will focus mostly on olive fruit fly and scale insects, which are some of the key pests that we have. And then I will spend some time briefly talking about tree borers that includes American plum borer and lilac borer, uh, which we have been seeing being increasing problem in the olive industry, it's at least in my region. So when we talk about olive fruit fly, it's a key pest of global significance. The map here shows some of the region of the world that produces olive and its distribution, the distribution of olive fruit fly in those regions. So it's a key pest of olive in North America, Southern Europe, and Northern Africa and Middle Eastern region. And in California, it was introduced it was detected first in the late 90s, and it didn't take this pest too long to spread out throughout the state. So now it's distributed throughout uh, the olive producing region in California. So when we talk about olive fruit fly, it causes damage to olive in multiple ways. So firstly, we are talking about the adult females that are equipped with specialized ovipositor that helps them lay eggs inside the olive fruits. And when they do that, they make these ovipositional stings that causes these uh, cosmetic damage mostly. And then when the eggs are deposited and when the eggs has there, the larvae feeds the fruit pulp. And when the larvae feeds on the fruit pulp, the infested fruit may drop, and that kind of leads to fruit being unmarketable for canning purposes. And that infestation also leads to increased susceptibility of those fruits to microbial infection. And that microbial infection basically affects the oil olives and it affects the oil quality as well. So it's a key pest, and it's a big problem. So there are a few reasons why this pest is such a problem. So first of all, it's widely spread in the state of California. It's pretty much present in all olive growing region. It's more problem in some region than others, but it's present everywhere. And if left untreated, it can cause 100% fruit infestation, depending on variety. So the other challenge we have is the larvae spends inside most of its time inside the fruit, or the insect spends most of its time protected from external exposure. So it protected from parasitoid or predators, and there is a challenge to control this insect using insecticides. So all these, because of all these reasons, this pest is very hard to manage, and it's a challenging pest to deal with in olive production system. So briefly talking about olive fruit fly, it's a typical fruit fly, colorful fly, looks beautiful when we just look at it, but very damaging. It's in the family Tephitidae. Some of the related insects or fly in this group includes apple maggots and walnut husk fly that many of us probably already deal with, and some of the other pests that maybe less common but of great significance are Mediterranean fruit fly and oriental fly. And this is a monophagous species. This fly is a monophagous species, mostly feeds on the tree related to olive, primarily feeds on the European olive or common olive, but can also attack other species of that group. So when we talk about their identification, so they're colorful flies, brown color with several dark markings on the body. They do have these white patches. I don't know if you can see these on the thoracic region. Several of them that's helpful to distinguish this fly from other flies present in the orchard. So they do have these clear wings with dark veins, and they have these small dark spots at the tip of their forewing. So that those all features help them distinguish from other fruit flies. So female has these this long ovipositor. With the male doesn't have it, so that this is the part of their body that they use to lay eggs inside the fruits. So all varieties that we grow in California are susceptible to fruit fly infestation, but some of the varieties, a study done by Frank Zellum and his graduate student quite a while ago, they found out some of the commonly cultivated table olive varieties are more susceptible to fruit flies. But those varieties include Sevillano, Manzanino, and so on. And some large size fruit olive oil varieties are also susceptible. So they are not only attracted to those large size fruit varieties, they have some survival benefit on those varieties as well. So for example, they found the pupa were much healthier and heavier. They developed faster on those large size varieties or the varieties they preferred, and they also survived as eggs more on those varieties. So other studies have shown that the size is just one factor when it comes to olive fruit fly preference to varieties. So other factors include volatile and the fruit firmness and things like that that also affect the varietal preference of this fly to different varieties of different cultivars of olives that we grow. So fruit fly it's a fly, tapeted fly. It has a complete life cycle. In California, it's typically has 3 uh, generation per year, but can have 4 generation in coastal areas. So they have this complete life cycle. They emerge during the spring and summer generation. They emerge as adults and they select their host. They find their host, that is olive fruit, and then they lay eggs there. The larva, the egg hatches, and the larva feeds inside the fruit pulp, and in the fruit pulp, it pupates there. So and then finally emerges. So it takes roughly about 1 month to do this to complete their life cycle. And one thing to kind of remember about olive fruit fly is during the spring and summer generation, the larva and pupa and egg, all of those 3 stages can develop inside the fruit. That is a little bit different in for the fall generation, where they have pretty much very similar life cycle. The female finds the fruit, lays eggs inside the egg hatches, larva feeds there. But at the later part of its development, when the larva is mature, they drop from the fruit to the soil or ground, and they pupate, and that's where they overwinter during the season. So in the fall generation, they drop from the fruit, and most of the population pupate and overwinters in the soil. To monitoring part of this pest. So monitoring is important for this pest. The monitoring, we have several different types of monitoring tools available. So one is Macphail trap that you can see in the first picture. Basically includes a bucket type of trap that is hung on the tree, and the bait, torulized bait is usually used with water. And we have Olive trap, similar kind of strategy. So water and torula based, and we have yellow sticky trap, which is baited with either ammonium bicarbonate or pheromone or both. So we have these 3 different types of traps. So when you are monitoring their population, you just follow the manufacturer's instruction. I think that's the key. And one thing when we talk about their monitoring is their monitoring doesn't provide us the threshold. So there is no trap capture-based threshold available for this pest, but the monitoring is important because it provides some level of population situation in the field. Also, the monitoring can be really handy when it comes to evaluating the efficacy of your treatment. So you have these traps that capture the fly population before the insecticide treatment and after the insecticide treatment, and you can evaluate if your treatment was effective. So there are several different types of traps, but study done by Frank Zellum and his students showed Makefield traps catch more flies. You can see the chart here with Makefield trap in red catching a lot more flies than other different types of traps. But in recent years, I have seen many growers and PCA use the yellow sticky trap with baits because it's easier to use. So, but if you're looking for an effective trap, Makefield trap is actually can be better. So let's talk about managing fruit flies. So one of the tools, especially used by small and organic growers for managing this pest, is mass trapping. So what this involves is basically, so you use the same tools and same baits and lures that we use for monitoring, but instead of using one or two of those traps for monitoring, people use higher density of these traps. So we're talking about one trap per tree. So we're deploying a lot of traps so that the traps catch a lot of those flies and reduce the population there. So this is not recommended in high population situation in standalone control method. It can help reduce or suppress the population, but may not provide effective control if you have higher population in your orchard. So the other tool we have for managing this pest is use of cultural practices. So this includes some of the tools such as sanitation, which is really handy. What basically this involves is removal or knockdown of fruit that were left on the trees at harvest. So after the harvest, you go back and remove them or knock down them from the tree, and you bury them or destroy them. And the other thing that you can do is landscape olive. If they're fruiting varieties, they can be a source. They can support the large number of fruit fly population, and removing those fruits that can support the fruit fly population from landscape olive is also critical, or can help manage this population of this fly. And there are some products available. I think it's called Olive Stop. It's a plant growth regulator that basically causes the flowers to abort and not prevent them from producing fruits. So there's those two chemical products available for that purpose as well. The other thing to consider is minimize black scale infestation. We'll talk about black scale infestation in a few minutes, but so the idea is black scale, they produce honeydew that can be a food source for olive fruit fly during the summer when there is lack of food source, and that can support the fruit fly population. So you're controlling the black scale infestation so that there is no or very little honeydew left for this species of fly to feed on and survive during the summer. So biocontrol, we have some generalist parasitoid, native ones, and some predators such as ants. They can do some level of control, but they're not very effective. So because of that, classical biocontrol program was started in early 2000s. Basically, that program involved exploring and identifying potential biocontrol agents in the native area where this insect is from, that is Africa. And they introduced 5 different species of parasitoid, and they tested and did some efficacy tests, and 2 species were released. That includes Citalia, 2 species of Citalia humilis and Citalia lounsbury. They're released throughout the state of California in several regions. And after several years of that release, we have found that one species, that lounsbury, has actually been established in coastal region in San Luis Obispo area, where they have been found to parasitoid about 40 to 70% of the population. The other species they introduced has not been established, and none of those species actually established in the Central Valley, where we have high temperature. So climatic So we have very hot. So the climatic mismatches and seasonal host gaps basically limited their establishment in the Central Valley. So we do not have any effective parasitoid that was introduced from other country in our region in the Central Valley. So if we're thinking about relying on biocontrol more, there is a need to explore more and find the species that is more adapted to the Central Valley climatic situation. So chemical control is one of the mostly used tools that we have. We have very limited number of insecticides. So the first one we have is insecticidal bait. So this typically it's usually sold at ZF120 fruit fly bait. So it's a spinosyn or spinosad based product. So it's usually applied at the rate of 10 to 20 ounce per acre. And of course, you mix this with the water. So the dilution rate is between 1.6 to 6 in the ratios of 1.6 to 6% portion of water. So the product is usually found effective when it's applied at larger droplet size in the area of the tree, which is kind of protected from the sun and into the upper canopy. So typically the spray with this product begins when fly numbers are increasing, but if it's warm spring, this can be as early as June 1st. And the use strategy or use approach is for this product is either you spray weekly to every other row, or you spray every row every other week. So that's the approach the growers usually use, and typically when that starts when the fruits become susceptible, usually around peat hardening stage, and that continues until harvest. So other tool that we have is, or other insecticide we have is a danitol or pyrethroid-based product, normally usually sold as danitol. So it's a penfluoperthrin. It's a broad spectrum insecticide. It's very effective for quick knockdown kind of situation when there is need for that. And so it's good coverage with this product is critical. So you were trying to cover the whole entire tree. So usually kind of it's applied with 100 gallon per acre of the water. So one of the things about using this product is it's a broad spectrum, so it can be very destructive to natural enemies if applied early in the season. So the recommendation or the suggestion is do not use it until before late August. So this is kind of like when you have the fly population really high late in the season and your spinosad based GF120 is not working. That's the time this group of pesticide comes in handy. So we do have another alternative material. It's not an insecticide per se. So it's a surround kaolin clay-based product. So it's a white powder you mix in water and you apply. And the idea is you are covering the entire tree, leaves, and then fruits throughout the season, so that the insect is deterred by this white coating on the fruit surface. So it's very effective, can be very effective, but to cover those trees throughout the season requires at least 2 to 3 applications every 5 to 6 weeks, and that can add up to the cost, can be very expensive. And the other concern about this product, using this product, is if you're a large grower. So I think there is going to be a need to wash off this coating from the fruit, and that can be a problem. But it's a very effective product otherwise. So wrapping up about fruit fly, I think we do have some challenges. So I think with fruit fly management, I think the challenge we have is we have very limited number of active ingredients available. So spinosad and pyrethroid, and so spinosad has been overused. And there was a study that came out in about 15 years ago, already indicating there was already moderate level of insecticide resistance going on against this group of pests, especially in areas where they uh, use this product extensively. So you can see almost 10-15% resistance ratio in some of the orchards in California. So that was olive fruit fly. Now I'll go ahead and start talking about scale insects, which is another important pest in California. Olives may not be present in all the orchards, but can be, when it's present, can be a challenging pest to manage. So it's good to be aware of this pest. So there are several scale insect species that attack olives. So that those species include some soft scales and some armored scale. So black scale is the soft scale that we have. I'll talk about what that means in coming slides. So we have other species such as olive scale, oleander scale, and California red scale. They can occasionally infest olives. And this group of insects are related to aphids and other hemipterans, and they have this piercing, sucking mouth, and they suck up the plant juice from the plant tissue, phloem part of the plant. And so they differ in their biology and the part of the plant they damage and their timing and things like that. So understanding all of that is, I think, critical for managing scale insects. So among the different scale insects we have, the black scale is probably the most well-known and probably most common. And it's a soft scale in the family Coccidae. What that soft scale means is the outer wax covering is relatively softer and is kind of very fixed or attached to the insect body itself. So it's hard to remove the insect from the covering. And one other thing to remember about this group of soft scale that is or black scale is they produce honeydew, which is basically a sweet, sugary, clear liquid that is very sticky. So they feed large amount of sap from the plant, and they excrete that honeydew that can have some impact, such as attracting ants and causing sooty mold and things like that. So this pest has one generation per year in the Central Valley and can have multiple generation in the coastal region. So it's mostly a problem in dense canopied unpruned orchards. So female of this species can be identified by this H, uppercase letter H shaped ridges on the back of their body. So they have eggs that the female covers them underneath that are small, tiny and orange or yellow in color, and the eggs hatch and they go through crawler and two more other stages before they become adults again. So when we talk about the damage, we're talking about the removing plant sap that reduces their vigor, and also we're talking about them removing large amount of honeydew, which makes the surface sticky and makes them susceptible to sooty mold growth, and all that can result in defoliation. That sooty mold and that black covering also blocks the sunlight, and that can interfere with photosynthesis. So we're talking about the vigor, loss in vigor, and the serious infestation can reduce bloom in the following year, and also the sticky black colored fruits can be kind of hard to pick, so they can interfere with the picking as well. So we have really well developed monitoring method for this pest. So I don't want to take too much time to talk about that. It's available in the UC IPM guidelines for this pest. So what this basically means is during April and October, you select 25 to 30 trees and you observe them for the honeydew accumulation. That's the time when a lot of honeydew accumulation takes place. So you're just estimating the population in the orchard. And the next thing you do is in May, you sample the adult insects from 2 to 3 areas in each block. And what that involves is you select 10 trees in each of those areas and you count the numbers of adults on the terminal 18 inches of the 10 branches on each tree. So you're sampling about 100 branches in one area, and you get the average level of infestation in that area by summing by totaling and dividing the total number of by the total number of branches, total number of scale by total number of branches that you sampled. So depending on how many average number of scale you got per branch, the infestation level can be categorized, has been categorized. So it can be light, moderate, heavy, and severe infestation level. And that basically, if you have less than 1 scale per branch, it would be categorized as light infestation, and 1 to 4 scale per branch would be moderate level of infestation. Yeah, and 4 to 10 would be heavy, and more than 10 would be severe infestation. So based on those infestation level, your management recommendation can change. For example, if you have very light information on the top in this table, if you have open canopy in orchard, no treatment is probably needed. Versus if you have closed canopy orchards, pruning or dormant oil spray can be sufficient. And however, if you have very severe infestation, for example, that can mean extension loss can occur in the next season. So that would require some extensive control approaches, such as pruning the damaged branches, applying insecticides, and so on. So for olive fruit fly management, black scale control, we have some cultural control tools available. The first thing we have is, as I mentioned earlier, they are a problem in dense closed canopies also. So pruning to open canopy to improve sunlight and reduce humidity can reduce the infestation of this pest. And the other thing I think that you can do is these insects, younger stages of these insects secrete this honeydew, as you can see in the slide. And those honeydew, they are sweet and sugary, and they attract these ants. And the ants they attract do not directly cause damage to the olive trees or olive fruits, but what they do is, so there is this good symbiotic relationship between scale insect, this honeydew producing scale insect, and ants, where the scale insect provides this honeydew, and the ants they protect the scale insects from their natural enemies, parasitoids. So if you have high level of scale insect and they have high population of ants, there may be need to control these ants so that the beneficial can do their job. So that's one cultural tool that we have, or we may have to consider in some situations. So there are several ant control products available. I'm not going to talk about those in today's presentation, but there are ant control products that are available to control these ants. So on biocontrol, there's natural enemies available. Some introduced natural enemies. They're effective and have been established, especially in the northern Sacramento Valley and coastal areas. Two groups of parasitoids they have been found effective. That includes a couple of species in the genus Metaphicus, and there is another genus Scutellista. So they can be very effective. The first group attacks scale nymphs, and the second group attacks the eggs, respectively. And one of the things to utilize or get rid of these enemies is to preserve the enemies by avoiding broad spectrum insecticides as much as possible, so that they don't get killed by the use of those insecticides. So on the scale insect control, I think there are two things. There are some products, oil can be effective in lower to medium kind of population situation. There are insecticides, some growth regulators, and carbamate group of insecticide available. I think two things to remember on their chemical control is I think avoiding an unnecessary sprays by utilizing the threshold that we have. And the other thing to consider is spray timing is very critical. So with scale insects, their adults are protected by that hard covering. So targeting crawler is important. For this group of pests, the egg start hatching. They have only one generation per year. So the egg start hatching in May to June, and targeting crawler in mid-July is the most effective timing for this group of pests. So the other, we have some other scale insects. They're in the other group of scale insects called hard scales or armory scale. They're in the scale insect family called Diaspiridae. So their covering is kind of hard, and they form this kind of incrustation that basically protects them or covers them. So this group of pests do not produce honeydew, so the honeydew is not a problem. So and there's at least 4 different species, or 4 or 5 different species of these hard scales or armory scale that we have in California olive. So olive scale, British scale, and Latania scale, oleander scale, California red scale, they look very similar, but we have some features that we can look at to tell them apart. I'm not going to go over that detail, but the information is here or is available in the UC IPM guidelines. And I think with this group of pests, we're mostly talking about direct feeding damage, because this scale can infest the fruit directly and can cause this kind of dimpling and malformation of the fruits. If they're present in high numbers, they can also infest branches, twigs, and leaves as well. And there are they can cause yield and quality reduction. And again, they do not produce honeydew, but can cause twig dieback and fruit blemishes. That's the major damage they're causing there. So for their monitoring and management, usually these pests are controlled by beneficials. But if you have seen some of their population in the previous years, and if you think the treatments may be necessary, there are treatments with same group of insecticides and oil that we talked in black scale can be used for managing this pest as well. Again, timing the crawler emergence is critical for this group of pests as well. So you can use double-sided sticky tape to monitor the crawler emergence, and that crawler emergence usually takes place in late May and June for the first brood and first generation, and then for the second brood, late July and August. So finally, we have these tree borers, which are more of an occasional pest, may not be present or are not present in all the orchard, but when they're present can be a serious problem. We actually have some growers and pest control advisors who contacted me on these pest issues. So usually the damage is they cause girdling of the trunks or limbs, and which can cause breaking of small branches. If there is high level of infestation, they can kill young trees. We have seen that happen. So there are 2 species of these tree borers that we have seen can be a problem. So the first group is American plum borer. It's a pyralid moth. The damage is done by the larva. You can see the adult and larva. So it is about 1 inch wingspan more. So sorry, the adult is about 1 inch wingspan moth. It's gray in color and has black markings on the wings. The larva is pinkish or dusky white, about 1 inch long. And the female, they preferably lay eggs near callus region of the callus tissues because the larvae, they prefer to feed on those callus tissues. Those callus tissues are normally found around pruning wounds and crown galls and scaphoid crotches. And once the larvae will eventually bore into the trees and feed on the vascular tissues there. So they have multiple generation each year, so 3 to 4 generation, and they overwinter as mature larvae in those protected area in the trees, and they form this kind of protected cocoon where they pupate. So in terms of their signs of infestation, it is difficult to find these life stages such as larvae and pupa because they are hidden or protected from the trees. But what you will usually see is this presence of this brownish frass and this webbings left there on the infested areas. They can also leave this gummy liquid exudate in those infested area around the injured woods. So other related species, other pests that we have as a tree borer is lilac borer. This is not listed as the pest of olive in the UC-IPM guidelines if you follow UC-IPM guidelines, but we have seen especially in some areas of southern Sacramento Valley and San Joaquin Valley, some people are dealing with this pest. So it's a moth. It looks like a wasp, but it's a moth in the clearwing family called Cecidae. The adults look like a wasp, but they do not have this stinger that a wasp would have. So they lay eggs on the tree bark. The larvae they bore into the heartwood. They pupate there and complete their life cycle, and they have only one generation per year, but they have very extended flight periods that can span throughout the summer. So that kind of makes it difficult to manage this pest. So lilac borer, the sign of infestation are very similar to the American plum borer that we talked earlier. So they will leave sawdust-like frass and sap oozing out of those infested wound, and they will have these exit holes. And I think one of the distinguishing their sign of infestation for this group of pests is these pupal skins or pupal exuviae they leave at the exit holes that you can see in the first picture, those pupal kind of mummy that sticks out from those exit holes. So for managing these tree borers group of pests, early detection of larvae is important because I think the main goal with this group of pests is to prevent them from building up population in large numbers, large population. Because with large population, they can cause by the time that they can cause very significant or substantial damage. And the other thing is the managing this pest can be very challenging if they already established in the orchard. So what we are typically suggest is inspecting trees in spring and summer for all the damage symptoms we talked about. So for their management, so removing and destroying infested wood can go a long way when it comes to removing or preventing their population from building up. And then the other thing is, especially for American plum borer, there are targeted sprays of some carbamide insecticide has been found effective in studies. And if the spray is followed by trunk painting by interior latex paint, that even works better. And for American plum borer, for lilac borer, we do not have efficacy data, but some of the studies done in other systems in other states have shown insecticides such as diamide group of chlorantraniliprole group of insecticide are effective against that pest. So for managing this pest, I think one of the important thing to consider is treatment timing, because all the insecticides that we just talked about, they are more effective. They're effective against the larvae And so how we can do that is we have traps and lures available for both of these pests. So you can deploy the trap, monitor them weekly, and uh, spray the insecticide at peak emergence timing. And that usually typically happens uh, mid to late April. And depending on how much population you have, what level of infestation you have, subsequent application may be necessary, especially for American plum borer. I think that's all I had for today's presentation. So I think I still have a few minutes left. So I will be here to take questions if you have any questions. Thank you.
Yes, thank you so much, Sudan. Yeah, there are several questions that came in, and we have a few minutes before we'll put that link to the test in the chat. So I'll go ahead and get started. So we had three different people asking the same question. So I'll start with that one. And that was about the kaolin clay. If wouldn't that reduce photosynthesis and hinder the growth of the tree?
So I think that's a concern in some of the other crops, especially I think like I have heard people talking about it effects on that photosynthesis and things like that in walnuts. I haven't heard that in olive. So I do not have the data, but I know some people, especially in the Bay Area, organic growers, they don't have a lot of tools available in the coastal areas. They use this product in a continuous basis. So uh, I have seen people do it, but I do not have, unfortunately, I do not have it, kind of detailed information on if and how this would affect the photosynthesis.
Okay, thank you. And then somebody just added a comment to the chat that said surround will not negatively impact photosynthesis.
Yeah, thank you. Whoever responded to that question.
Okay, so and then another question that came in is my understanding of pesticide use is that we cannot put pesticides into food containers. Have you spoken with DPR about the use of water bottles in olive traps to make sure it is okay from their perspective?
Uh, yeah, that's a very good question. Yeah, so yeah, I can check on that from DPR. I think those are actually traps, like that those bottles. It may look like a water bottle, but they can actually be a special type of containers that are used for that particular purpose.
Okay, thank you. And then uh, David had a question or a comment about the photos of olive fruit fly used in the slides are of the atypical yellow morph rather than the typical morph with the gray thorax and dark abdomen with a yellowish T
Oh, is that for the?
for the olive fruit fly
Oh, okay.
photos.
Yeah, I think I found that in those photo. I wanted to use kind of. I think they came from Georgia, University of Georgia, their photo bank. So I didn't think about that, but yeah, you may be right. So I wanted to show kind of all the features that helps to identify these species. So yeah, that may be why I use these photos, because these photos had all those features kind of shown in the photo. But yeah, thanks for the comment.
Okay, and then another question, any thoughts about canker? Can it be prevented?
Canker. Sorry, yeah, I think like no, I do not have the right answer for that. Honestly, I am an entomologist, but I can get back to you if you can email me or email Cheryl with that question. I can definitely get back to you on your question on canker.
Okay, thank you. And then how can we manage scale insect first nymphal instar with the sticky tapes that you mentioned?
So that is sticky tape. I think that's a very good question. Sorry for the confusion, but the sticky tape is actually for monitoring. So you're kind of trying to find out when they emerge as a crawler so that you can apply the insecticide or oil. So it's not for managing the scale insects per se. So we're not using the tape to kill the scale insect or crawler. It's to monitor their emergence.
All right, thanks. And then the next one is, has there been any success with insecticidal soaps managing soft scales? Could they be useful in addressing sooty mold prior to rainfall?
So on that question, I think, uh, I mean, there should be, I'm not aware of any studies. If any studies has looked at controlling the species of scale insect that we're talking about using insecticidal soap, but I would uh, think it should be effective against again, like a lot of things come into play. So how much pressure you have, and their phenology, and how accurately you could time the most of the crawler population. So all of that will have an effect, but the insecticidal soap should help control this pest.
All right, and I think we just have time for one more. This one is, are the black scale biocontrol natural enemies commercially available for purchase and release? Is this suggested or effective for olives in the Central Valley?
Okay, sorry, I kind of lost your question a little bit. So can you repeat the question again?
Yes, yeah. Are the black scale biocontrol natural enemies, are they commercially available for purchase and release? And is this suggested or effective for olives in the Central Valley?
So yeah, I do not have answer to that question, but I can definitely look into if there are any commercial insectary that provide uh, those species that we just talked about to control black scale. So yeah, you can email me and I can find an answer to that question.
All right. Well, thank you so much for your presentation. It was very interesting, and I think we had a lot of attendance today. So thank you so much.
Yeah, thank you. Thank you everyone for your attention and for participating. Thank you.
We hope you guys all have a good rest of the day, and we will see you back at another webinar. All right. Thanks, everybody.